Next topic is system of homogeneous equation. In this also, we have three equations and the system of equations are said to be homogeneous whenever its constants are zero. Whenever the system of equations constants are zero, that is instead of d1, d2, d3, we have 0, 0, 0, then we call those equations as system of homogeneous equations. We have already know that delta is calculated by all the coefficients of x, y, and z. But what's the different case in this? Here, if you see delta x, delta y, and delta z, we know this system of homogeneous equations, the constants, those are d1, d2, d3, will be 0, 0, 0. So, automatically, delta x will be 0, delta y will be 0, and delta z will be 0. And here, using the formula, that is x is equal to delta x, delta is equal to delta x, and y into delta equal to delta y, and z into delta equal to delta z. We have just seen that these delta x, delta y, and delta z are 0 for the homogeneous equations. So automatically x will be 0, y will be 0, and z will be 0. And this is possible only when this delta is not equal to 0. Okay. So this is the basic solution. So this is basically the case 1. That is a unique solution. So in question, if it asks a unique solution, then we can use that delta is not equal to 0 and delta x equal to delta y equal to delta z are equal to 0. Hence, x, y, z are equal to 0. And the next case is case 2. Here, no solution can't be a case because we have a unique solution compulsory. So how can these equations have a no solution case? So the case 2 is infinitely many solutions. So these kind of system of equation has only two cases, that is a unique solution and infinitely many solutions. So here the main condition is delta is equal to 0. This is the case which we used to find the infinite solution. So this system of equations has only two cases, that is a unique solution and one more is a infinite solutions. In unique solution, delta is not equal to 0 and the other three deltas, delta x, delta y, delta z are equal to 0. Whereas in infinitely many solution case, delta is equal to 0. And before we go to the questions, there are two terms you need to know. Those are trivial and non-trivial solutions. One is called as a trivial solution and one more, it is called as a non-trivial solution. So what this solution actually means? In the system of homogeneous equation, trivial solution is when a unique solution exists. That is, when all x, y, z are equal to 0, then we say it is a trivial solution, and here in this case delta is not equal to 0. Non-trivial solution is nothing but non-zero solution. It's also called as non-zero solution, which is nothing but the case 2, that is infinitely many solution, and here delta is equal to 0. These terms are very important because in questions they gonna use these kind of terms and might get trickier for you. So before in hand you should know about all these terms so that you can solve the questions. So let's get into the questions now. In this question, we need to find the value of theta for which the system of linear equations are given to you, these three. And it is said to be that these system of homogeneous equation have a non-trivial solution or non-trivial solution. So for the non-trivial solution, what's the first thing we need to do? For the non-trivial solution, it is a non-zero solution. So infinitely many solution, delta should be equal to 0. So let's calculate the delta. That is, take the coefficients. Sine 3 theta minus 1, 1. Cos 2 theta, 4, 3, 2, 7 and 7. Just calculate the determinant. You can use any row column transformations, but you can directly open the determinant also. So here, let's open it directly. Sine 3 theta, 7 4s are 28, 7 3s are 21, minus into minus plus 1, 7 cos 2 theta minus 6, plus 1, 7 cos 2 theta minus 8, and this is equal to 0. So it becomes 7 sine 3 theta plus 7 cos 2 theta minus 6 plus 7 cos 2 theta minus 8. So it will be 7 sine 3 theta plus 14 cos 2 theta minus 14 equal to 0. You can take 7 common from this, so it becomes sine 3 theta plus 2 cos 2 theta minus 2. So just apply the formula. Sine 3 theta is nothing but 3 sine theta minus 4 sine cube theta plus 2 cos theta. Write in terms of sine, so that whole equation will be in sine terms. 1 minus 2 sine square theta minus 2. So just simplify this. It becomes minus 4 sine cube theta as it is. Minus 4 and plus 1, sorry, minus 4 sine square theta plus 3 sine theta, and plus 2 minus 2 gets cancelled, so this will be equal to 0. So you can take minus sine theta common from this, and remaining will be 4 sine square theta plus 4 sine theta minus 3 equal to 0. So there are two cases. Case 1, that is sine theta equal to 0. And here, what's the solution of theta? We have already learned in the trigonometric equation. So it becomes n pi. And what is the case 2? It is 4 sine square theta plus 4 sine theta minus 3 equal to 0. So here you can apply the quadratic equation or splitting the middle terms method. It becomes 4 sine square theta plus 6 sine theta minus 2 sine theta minus 3 equal to 0. So take 2 sine theta common from here. So it becomes 2 sine theta plus 3. Take minus 1 common. So 2 sine theta minus plus 3 equal to 0. So what are the factors over here? 2 sine theta minus 1 and 2 sine theta plus 3. These are the two factors. And again from here we have two different solutions. That is sine theta equal to half. One more is sine theta equal to minus 3 by 2. And this is not possible because we know the sine theta lies between minus 1 to 1. So it doesn't lie in the range. So here, if we calculate the general solution of theta, theta is nothing but n pi plus minus 1 whole power n pi by 6. And now, when you talk about the common solutions from these two, you will get the final answer as this only, that is theta equal to n pi plus minus 1 whole power n pi by 6. So if you see the option, third option is the correct answer to this question. In this question, system of linear equations are given to you. Those are these three equations. And if you observe in these three equations, the constants are 0. So it is said to be a homogeneous equation. And it is told that these have a non-zero solution, which means a non-trivial solution. That is, delta is equal to 0. So let's calculate it. That is 1, 2a, a. I'm writing x, y, z coefficients. 1, 3b, b, 1, 4C and C. This determinant value should be equal to 0. So let's apply some column and row transformation. So first column 2 changes to column 2 minus 2 times of column 3. So column 1 and column 3 remains as it is. Only the column 2 changes to C2 minus 2 times of C3. So 2A minus 2 times of A, that is 0. 3B minus 2B, B, 4C minus 2C, that is 2C. Okay. Next, and this is equal to 0. Next, apply the row transformation. R3 changes to R3 minus R2. So R1 and R2 remain as it is. 1, B, B. R3, that is 1 minus R2, again 1, 0. 2C minus B. Next, C minus B. And this is equal to 0. Next, let's apply R2 changes to R2 minus R1. I'm just making as many as zeros in the elements of the determinant so that you can easily calculate the determinant. So R1 remain as it is and R3 also remain as it is. So R2 changes to R2 minus R1, that is 1 minus 1, 0, B minus 0, B, and B minus A. And this is equal to 0. So let's calculate the determinant, that is 1 into BC minus B square minus B minus A into 2C minus B. And 0 into something is equal to 0, and A, this determinant is 0, so this is equal to 0. So just open it, BC minus B square minus 2CB plus B square plus 2AC minus AB equal to 0. So this gets cancelled. This is minus BC minus AB equal to minus 2AC. That is AB plus BC equal to 2 times of AC. This can be written as, just divide both the sides with B. I'm dividing both the sides with B. So it becomes, no, I'll divide with all the terms, that is ABC, okay? So that AB gets cancelled and we'll get 1 by C. This BC gets cancelled, 1 by A. And here AC gets cancelled, just 2 by B. So from here we can say that A, B, C are in HP, right? This is the condition for the harmonic progression. So according to the options, option 3, C is the correct answer to this question.